Do you keep writing the same messy code again and again? What if I told you there's a smarter way, proven patterns that top developers use to build scalable, maintainable apps? Today, we'll master 5 design patterns: Singleton, Factory, Strategy, Observer, and Decorator, with real code examples. Let's dive in. So here I have initialized npm and I have created a folder called src. So let us see the first design pattern. So the first design pattern is Singleton Pattern. So let us create a file called singleton.ts. Now what does Singleton Pattern mean? So Singleton design pattern means that one class can have only one instance. So if you create a class called database, the database can have only one object. When you have a database, you only want to connect to the database once. There is no point of connecting to the database again and again. So once you connect to the database, you can query the database as much as you want. So let us code the same example that I just discussed. So I'm going to create a class called database, and inside database class, I will create a static field, private static, and let us name as instance, and this is going to be of type database. So this is a field. Now what I want to do is I want to create a private constructor. So I don't want user to create object on their own, because I only want the user to create one object. So I will make sure that the user will not be able to do new database and create object. So I will make the constructor as private. And what I can do is I can do console.log database connected. So once I do private, now I have only access to the constructor inside the database class and not outside. So now I'll create an instance called getInstance, which will be static. So getInstance. Now this is the method that user will call by doing database.getInstance, and I will return the object. So first of all, I need to check if the object has already been created. If the object has already been created, then there is no point of making the object again. So if there is no object, database.instance. So if database.instance is undefined, then I want to create a new database, and I want to store that in database.instance. So if there is no object, then I'll create an object, and if there is already an object, then I want to simply return that object. I don't want to create the object again. So let's create another method called SQL, just for making it look real. So let us say it has a parameter query of type string, and we will just return a very basic console.log executing whatever the query that user passed. So a very basic implementation of Singleton pattern. I hope you understood. Now let us use this class. So let's say, okay, uses. So let's say I want to create an instance. So I will create an instance by doing database.getInstance, and now I will store that in db1. And also let us try creating another instance. So db2 equals to database.getInstance. So let's analyze what happens. When I do first database.getInstance, it will create a new database and then return the instance in db1. After storing the instance in db1, when I do database.getInstance, the condition will fail, and then it will just return the instance that was created previously. So which means that db1 and db2 should be same. So if db1 and db2 is same, then this proves that we have correctly implemented Singleton pattern. So this is Singleton pattern design. So let's also implement that query method. So db1.query SQL, and let's pass query. So select asterisk from YouTube. So let us implement this. So in my package.json, I have already created a start script. So inside src, it will run singleton.ts. So I can just do, let me clear the console, and I can just do npm run start. Okay, there was an error. So ts node not found. Okay, I need to do npm I. So okay, the dependencies has been installed. We need to create tsconfig.json file. So let us create tsconfig.json file, and inside ts.config.json file, I will paste some default code. Let us save this. Now everything should be fine, and let us do npm run start. And we can see that singleton.ts has been executed. You can see database connected. So, and this is Singleton pattern design, which means that the object was not created twice. In fact, the same object was returned in the second time, and we have executing select asterisk from YouTube. So the next design pattern is factory design pattern. So let me create a file called factory.typescript. And what does factory design pattern mean? In factory design pattern, we hide the object creation logic. So we don't want the user to create the object because the object creation logic can be complex, or for whatever reason, we don't want to expose the object creation logic, or we don't want the user to create the object. In fact, we just want user to pass something and then we will handle creation of objects. So let us implement factory design pattern. So first of all, I'll create an interface called food. And inside food, I'll create a method called void. Now, whatever class that implements this interface should compulsorily use this method. So let me create a class called pizza, and this should implement the food interface. And as I showed you, the cook method should be compulsorily implemented. And let us just do a very simple console.log cooking pizza. So after this, I can create, let us also create another class called, let us create a similar class. So let me just copy and paste. So chicken implements food and cooking chicken. So now let us create a base class, and which is something I'm going to be naming as food factory. So this food factory class is useful for creating objects. So it will create chicken object, pizza object. Now user will pass what object they want to create, and this class will basically create that object and return that object. So let's see how we do that. So I will create a method which is going to be a static method. So get instance. So this method will return the instance. So user will basically pass me a string, so the name of the food, and I will return the instance. So user will pass me which food they want. So they can pass chicken or pizza, and then I will return the object of pizza or chicken. So for that, let us do a very basic switch case statement. So I want to switch between food, and if the food is pizza, I don't want to break. So I simply want to return pizza, new pizza. So it will create object of pizza and it will return that. And similarly, I want to create another case where user might pass chicken and return new chicken. So okay, we have returned for both of these cases, and default, if user don't pass pizza or chicken and pass something random, then we will throw an error, throw new error, and let us say error occurred, and we are returning this object. So okay, so this is implementation of factory pattern. Now let us use this. So let me add a comment, uses, and I will provide this code in the GitHub, so don't worry. So let us implement this food factory and get the object that we want. So let us do food factory dot get instance, and I just simply pass what object I want. So I want chicken. So in outside, while using, I don't do new chicken or something else. So this is what factory pattern means. Instead of doing this, we just pass something to the factory class, and that will return me the object. So obviously this will return me the object. Let us store this in the variable const chicken1. See, it's a chicken1, and let us call one of the method. So chicken1.cook. So this is the method that should be implemented. So chicken1.cook. So very quickly, let us edit our start script, and this time it should run factory.ts. So let us open our terminal, and firstly let us clear and let us run the start script. So we can see that cooking chicken. Why cooking chicken is showing? Because this has returned me the chicken instance, and we are calling the cook method from the chicken object. So that's why we're getting this as the output. So I hope you understood about factory design pattern. Okay, so the next design pattern is strategy pattern. So let me create a file, strategy.ts. And what strategy design pattern means is that instead of creating a very huge if-else logic in a single class, so we want to divide the if-else logic in separate classes. So let me explain what I mean by coding. So let us create an interface called payment method. If you don't understood what I just said, you should be able to understand once we code this. So I will create a method called void, and I want a class to implement this payment method. So basically the scenario is that we have many payment methods. So one can be credit card payment, one can be PayPal payment, one can be crypto payment. Now based on several conditions, we will run the logic for PayPal payment, crypto payment, or credit card payment. So instead of creating the if-else logic in a single class, what we're doing is that we're creating separate classes for executing the logic for credit card payment, PayPal payment, and crypto payment. So let us create a class which is responsible for credit card payment logic. So credit card payment and implements payment method. So this should implement payment method, and basically this should use the pay method. And let us just do console.log credit card payment. So ideally this should be the logic for credit card payment, but this time we are just doing a very basic console.log. Now similar to this, let us create two more classes for different payment methods. So one can be PayPal payment, and let us do PayPal payment. And also we need another class for crypto payment, crypto payment. So now I want to create a base class called payment class. So let us create a class called payment. So payment, and inside this class I will create a field. So that field should be private. So payment method, and this should be of the type payment method. So this field will store the object for any of this class. So we have a field. Now we will create a constructor. In that constructor I will accept the payment method. So I will accept one of the object of these classes. So this should be of the type payment method, and then we will store this in payment method equals to payment method. Now we want to set payment. So maybe once user can do using credit card, and then they might do with PayPal, so they might change the payment method. So we need to create a setter. So set payment, and we will take payment method, very similar to the constructor payment method, and this dot payment method equals to payment method. And now we will create a method called pay, and we will whatever the object user has passed, so this dot payment method, and we will execute pay method. So suppose user passed an object of PayPal payment, then it will run the method pay for PayPal payment. So whatever the object user passed, it will run payment for that respective object. So let us use this. And by the way, you might have already guessed why we used strategy pattern, because if we had not used strategy pattern, then we would have to do a very big if else logic, like if payment method is crypto payment, then execute some logic, if else, and it would be a very big if else logic. So rather than doing that, for each payment method we create a separate class, and then we invoke the method for that specific object. So let's see how to use this. So we will create a variable payment, and we will create a new payment object. So inside this payment I need to pass payment methods. So new, let's say I want to do credit card payment. After doing this, I can do payment.pay, and it will call the pay method for credit card payment. So it will call this method, and we should see credit card payment. So quickly in my package.json, let me do strategy.ts, and let us execute the start script, clear npm runs start. So we can see credit card payment means the logic for credit card payment has been successfully implemented. And let's say I want to change the payment, so I can do payment dot set payment as I can pass new PayPal payment, and then if I again call payment dot pay, then it should implement the logic for PayPal payment. So you can see credit card payment for this, and then finally we have PayPal payment. I hope you understood strategy pattern. Now let us move on to the next design pattern. So now the next design pattern is observer pattern. So suppose you have an object called, let's say you have YouTube. So once you have an object called YouTube, there will be several other objects, like there can be several other objects, like let's say you have a subscriber for a YouTube channel. So this can be subscriber 1, is subscriber 2. Now what observer pattern says is that when the state of YouTube changes, then it should automatically notify subscriber 1 and subscriber 2. In real world, what this means is that suppose you have subscribed to my YouTube channel, and if I upload a new YouTube video, then you should be notified once I upload a new video. So this is what observer pattern says. There will be an object which is called subject, and there will be several other objects that are watching for changes to happen in this subject. And once the state of this subject changes, then I should notify all the objects that are watching this subject. So let us implement this in code and you will understand exactly what I mean. Let us create a new file called observer.ts, and very quickly in our package.json, let us change this to observer. So okay, so as I told you, there should be a subject like YouTube channel. So there should be a subject, there should be an observer. So for each of those, let us create an interface. So I'll create an interface for observer. And by the way, if you don't understand while I'm coding, you will exactly understand what observer pattern is once we implement this code. So don't worry, just stay with me now. So I will create a, so I want to create a contract called update method, and update method should take in a display string and void. So interface has a method update and it should take a string which is display and should return nothing. So again, for observer we have created an interface and there should be a subject like YouTube channel, and for that I will create another interface called subject. Let us do spelling correct. Now here in subject I want different methods. So first is I want to have a list of the observers. I want to know which observers are looking at me. So basically what I mean to say is that there can be several observers that are observing the subject. So I want to know which observers are observing me. So I want a list of the subscribers inside the subject, and also I want a method to add subscribers, to remove subscribers, and a method to notify the subscribers when I add a new YouTube video. So back to our code. So first of all, I need add observer. So I need a method to add a new observer, like adding a new subscriber. So this will be, let's say, observer, and this will be of the type observer, and this should return nothing. So another thing, so this will be the object of observer, right? So another method that I need is remove observer of type observer, and this should also return nothing, void. And another is a method that I need to notify all the observers. So notify observer, this should take a display which is of type string and void. So now I have to create subject. So class YouTube channel, and this will implement subject. So implements subject. So inside here I need to create a field that will store all the observers. So let's create that field. So private observers, and this will basically be array of observers, and initially we want empty. So now I have to implement these all methods. So first is add observer. So add observer, when we call this method, then I want to add observers in the observers list. So this dot observers dot, we have a method called push, and we want to push whatever that is being passed. So inside this list we are passing the observer. And similarly for removing observer, so remove observer, what we'll do is this will be slightly different. So we need to remove observer from the observers list by filtering. So this dot observers dot filter, and by filtering we'll have, for each observer we want to check the observers should not be equal to the observer. So by removing the observer, then we have the other remaining observers remaining in the list. So we are removing the current observer that is being passed. So another method that I need to implement is notify observer. And in this, I need to loop through all the observers, then I need to notify each observer. So I need to loop. So for let observer of this dot observers. So once I have all the observers, so I have to call the observer and the respective update method, and I'll pass display. So I will iterate through all the observers, and I'll call the update method and pass whatever the string is being passed to this method. So I have created a subject. Now I need to create subscriber, which is the observer, right? So let's say class subscriber, and this should implement that. Subscriber spelling is wrong. So I will create a constructor. So I need to give user a way to create subscriber. So for a YouTube channel, there can be many subscribers. So I will give a way to create new objects for this class. So I will have a string. So user have to pass a display, and from there I need to implement update method. And inside update method, I can just do a very simple console.log. I can do, okay, this will run when I add a new video. So let us create add new video method in this class. And I can basically, when user add a new video, I can do this dot notify observer. I can run this method. So this will notify new observer, and I can accept displays, which is going to be of type string, and I'll pass this string here, and this would call this, and inside this I will get display and new video uploaded. Let us also do display. So I hope you understood this. This was a very basic implementation. So you have a YouTube channel which is a subject, and when the state of YouTube channel changes, like when we add a new video, this will call notify observer, and notify observer will call the respective method for each update, and it will console.log this. So whenever I upload a new video, then user should get this notification. So let us see how this will be used. So users, and I can do const YouTube equals to new YouTube channel. So I create a new YouTube channel, and for that YouTube channel there can be many subscribers. So subscriber 1 is new subscriber. I need to pass the name, so I can pass something like S1, and let us create 2 subscribers at this time. So S2 equals to new subscriber and S2. Now let's say in YouTube channel I add a new video. So once I add a new video, so let me add a video title. So design patterns. So once I upload this video, then this will be running, and this should run this, and I should get everything. So let's run start script, and let's see if this works or not. So npm run start. So okay, we're getting nothing because we have created the instance of subscriber, but we have not yet added into this. So for that I need to do yt youtube dot add observer, and I need to pass s1, and similarly I need to pass s2. And once I do this and run npm run start, I should see the notifications being passed to both of the subscribers. You can see I added a new video, and the notifications has been sent to both subscribers. So in this way, what we're doing is that we have a subject called YouTube channel, and once the internal state of this YouTube channel changes, then we will notify the subscriber, and this is what observer pattern means. So now the next design pattern is decorator pattern. So let me create decorator.typescript. In decorator pattern, what it focuses is that suppose you have a base class and you want to now extend the functionality for the base class. So what we will do? So typically, I think you would have changed the class again and again and again and again, and that might introduce new bugs to the class. Instead of doing that, what we will do is we will add decorators, which means that on top of the base class, we will keep on adding functionalities, but then we will not change the existing code. So So let me explain what I mean by this. So let us code and then you will understand what I really mean. So let me create an interface called coffee. So interface called coffee, and inside this I will have two methods. So first will be price, which will return number, and second will be description, which will return string. Why am I having trouble typing? So okay, first of all I will create a very simple coffee class. So very simple coffee class, and this will implement the interface that I just created, which is coffee. And let's say price, let us return 5, and for description let us return simple coffee. Now I need to create a decorator base. So I will create decorator base because in the future I need to create new variations of coffee. Maybe I need to add milk to the coffee, maybe I need to add sugar to the coffee, and if I add milk the price might change. If I add sugar, the price might be even higher. So I need to create a decorator base. So let me create decorator base. So class coffee decorator. This should implement the coffee interface, coffee, and I will create protected coffee, which will be of coffee. So this will store the object. So okay, we have created a field. Now we'll create a constructor. So constructor, we will accept the object, so coffee, and we will populate the field. So coffee equals to coffee. So now we need to implement both the methods. First, this dot coffee dot price. So this will return whatever the base price is, and again we have description. So this will again call the object this dot coffee dot this price. Basically this is description method of the object that is being passed. So this will again return the simple coffee. Now let's say in future I want to add further functionalities, like maybe I want to add milk to the simple coffee, and then the price and description might change. So for that, what I will do is I'll create a new decorator called milk decorator. So I'll create class milk decorator, and I will extend my coffee decorator class. So once I extend the coffee decorator class, I can override this method and change the price and description based on the functionalities. So I can extend coffee decorator, and then I can override price method. So I can coffee dot price, in my base price I can add 2, which means that if you add milk, then increase the price by 2. And similarly in description I can do return this dot coffee dot description, and I can do something like milk has been added. So similarly, let us create another class sugar decorator, and this will extend coffee decorator, and let us override price method. So in the base, this dot coffee dot price, in the base price I want to add, let's say 1. If you add sugar, then price will be incremented by 1. So again let us also change the description. So this dot coffee dot description, and let us append sugar. So now let us use this uses. So first of all, let me create my coffee, and let us first create a simple coffee. Now let's say I want to add milk to the simple coffee. So what I'll do is my coffee equals to new milk decorator, and inside milk decorator I need to pass my coffee. So once I add my coffee, then the price will be incremented and description will be implemented. So let us further add sugar, and then let us console.log. So new sugar decorator, pass my coffee, which is the coffee after adding milk, and now let us console.log my coffee dot description, And let us also console.log mycoffee.price. Basically we are calling this. So okay, inside package.json, let us quickly do decorator.ts. Now let us run the start script and let's see the price after adding milk and sugar to the simple coffee. So clear the terminal, let us start the run the start script, and we can see the final price is 8 because the base price was 5, and after adding milk we have 2, 5, 2, 7 and then 8, and simple coffee, milk and sugar. In this way, in our base simple coffee class, we are adding new functionalities, and according to that we are changing the methods. So in this way, the decorator pattern helps to add new functionalities without editing the old class again and again. I hope you learned all 5 design patterns. So I'll see you in the next one, and obviously I'll provide the code in GitHub. I'll provide the link in the description as well as in the comment section. I'll see you in the next one. Goodbye.